Welcome back, everybody. You are watching the Artificial Intelligence live stream. This is the stream where we talk about all kinds of artificial intelligence subjects, everything from LLMs to vibe coding to generative art, everything in between, how you can apply AI. But so many of you are game developers. We always talk about games and game dev, and that is going to be for sure one of the topics that we cover today. So we're going to go in deep, but we're going to start high. Before we jump into what my friends from DevStream Labs do, just want to let you know that I am John Radoff. I am one of the founders and the CEO of a company called Beamable. We build infrastructure for game developers. So if you need game servers, online economies, social systems, chat, real-time multiplayer, like we do all of that. We are a tech stack to support all of the back-end needs of your game. So you can think front-end, Unity, Unreal Engine, and HTML5, JavaScript games. We have SDKs for all of the above. That sits on top of our backend. That's all you need. You start just building your game and building a great one. So that's what we do. I love to talk to people from AI, from game development, game developers in the trenches, people in decentralized technology. But this is the AI topic. So I'm going to introduce my friends from DevStream Labs now. So before we get into the problem you guys solve, can we start with just your own personal story? Like, what led you to this point in time and space on this stream today, ready to talk about what we're going to cover? Do you want to, who wants to start? We got two of you.
I can go first. Hey, all right, thanks, John. It's super exciting to be here. Really appreciate you guys inviting us to join and participate. So my name's Brent. I'm the CEO of DevStream Labs. My background is pretty extensive in the games and entertainment industry. I actually started my career out at Apple working on very early 3D hardware technology. I've worked at Bungie. I've worked at Avid on Pro Tools and the Avid Video Workstation. I've worked at DreamWorks Animation. I started a company with Alex Seropian and Tim Harris called Industrial Toys. We started that in 2012, and we got acquired by Electronic Arts in 2018. And then after that, I started another company with Stephen McDonald called Magic Potion Games. And then from there, I saw the business need for what we're doing at DevStream Labs, so I started that. So that's my background.
Awesome. And Bruce, tell us about yourself.
Yes. Super excited to be here. Very grateful for the opportunity, John. I think what Beamable does is fabulous. I think we have a synergistic point of view of the game dev space. My background is I spent almost a decade and a half doing automation and optimization for hardware software systems at Shell, and then saw the emergence of machine learning and artificial intelligence as the natural evolution of control systems and optimization and of automation. So went back to school, got a master's degree in data science, and was lucky to get onto Brent's team as an intern starting out. At Industrial Toys at Electronic Arts. We were building Battlefield Mobile. It was such a great time. It was an amazing team, amazing product. And from there, after Industrial Toys was sold, I went on to help build FC and FIFA Mobile. Was also amazing, and now I'm super excited to be here running AI systems for DevStream Labs.
Awesome.
Okay, I also have the privilege of teaching applied AI to executives at UC Berkeley. So if anybody has any questions about other industries in that space, happy to talk about that as well.
Awesome. So you guys have tremendous experience, lots of credibility. It's what we love to cover on this program, like people actually building real stuff, because there's just so much bullshit out there, frankly. So love to talk to real or helping other people build real stuff. So let's talk about that. So let's take it through the problem that you solve and like start there, and then we'll kind of dive into like the AI aspects.
Yeah, sure. Thanks, John. Yeah, so I'll start out. Bruce, you can chime in whenever you feel like you have something to add. But really, I started this company based off of a problem that I kind of hit over and over again in the development space, which is how you approach building your product. Like at Battlefield Mobile at EA, we had over 30 engineers, and throughout the day they would just be doing multiple check-ins, and there'd be like one nightly build, and then most of the time, maybe 50% of the time that nightly build didn't work. And then it would take away from our lead engineers' time because they would have to go spend time figuring out why did the nightly build not compile, which of the check-ins, didn't, cause the broken build. And then even once we got a good build, like, did it work? Could you actually do a play test on it? And that also was like, very challenging. So we found that we only hit our play test goals for, a fraction of what our goals were. And so I started, kind of seeing this pattern just, throughout being in, my career at so many different places. And I thought, how people build their product, that's not something that's like really differentiating. No one plays Call of Duty, no one plays Battlefield Mobile because they have a great infrastructure, a great build system, right? It's like, that's totally not what game developers want to do. No one becomes a game developer because they want to work on build systems. It's something that, I think, people kind of do, reluctantly, or maybe if you're lucky, you have someone who is actually interested in it, but that's kind of rare. And so I really saw the broken build as a productivity killer, as a morale killer, as a big pain point. And when you have a broken build and you have people sitting around that can't check in because the build's broken, that is costing, game developers and publishers, millions of dollars when you have a team that can't be productive. And so I really wanted to turn that around. I wanted to essentially take the problem of having to do builds away from, developers that just want to make games, and we just provide that service. So we can work with an existing source control system, or we host our own source control systems, GitHub or Git or Perforce. We also can connect to GitHub. And then it's super easy to set up. You just create an organization on our website. Then you can create a project. An organization can have multiple projects. And then from there, you can create, if you want to have us host your source control, it's like one click. Like one click, you can create a Perforce server. There's no need that it needs to be anything more complicated than that. Same thing with Git, or just, connect to GitHub. And then another click, and you've got a build farm. And then we set it up so that anytime someone does a check-in, we do a build. So you get one build per check-in. And so immediately if something's broken the build so that you can fix it right away. Then also we have technology that looks at what changed and creates a series of test steps that can be performed specific to that check-in for that build. So you can build and you can test every check-in. So that your source code is always stable. And that is a priority of the team to make sure that the source code is always stable. And when that happens, a lot of good things happen. First, developers have a lot more confidence that the current set of sources are stable. Sometimes that's a big incentive that developers don't want to update their code because they're worried about it being unstable. The second thing is you can obviously verify the code is always working because you're doing test steps. You have a bug log. So when a bug was introduced for which check-in. And then when you get to the polishing and finishing stages, you now have a fairly accurate backlog of bugs that you need to go through. And if you need to go back in time and fix a bug that maybe was introduced 5 months ago because it wasn't a priority then, but it's a priority for shipping because you know exactly what check-in caused the bug, you can go look at those sources. And that makes it 10 times easier to fix the bug. So you now have a much more predictable ship time because you have much more predictable polishing and bug fixing stage, which is traditionally the most unpredictable part of any project. So that's just a little bit about us and what we do. We have like a whole AI component for helping people diagnose broken builds, and I want to let Bruce talk about that because he created that system.
We're here on the AI live stream. So, but before we get to the AI component, just to maybe net it out a little bit. So the typical way teams of that size work together is everyone's checking in their piece. They might be doing local builds to test it on their own computer. I mean, we used to not be very happy back at Disruptor Beam, the studio I ran, if people checked in something that didn't even build on their local machine, everyone would get annoyed by that. But let's say that you don't have too big of a problem with that. Like people are doing a local build, at least built, they check in their change. You're kind of aggregating across the course of the day all those check-ins that lots of developers are putting in. And I think for most of what we were doing continuous integration, but we would end up with kind of the nightly build, because to do a real full build, we'd had to also bring in a lot of assets and all kinds of stuff was going on. So we did the nightly build. And the problem there is because there's a lot of different contributions happening at the same time, you can still break the build because people are in conflict with each other. For example, there might be a merge issue that didn't merge clean.
Exactly.
Types
Yeah,
of problems.
in addition to that, when a developer is not confident that the current set of sources are stable, they're reluctant to update. So someone may make a change on a set of sources from like 3 days ago, and it works and compiles on their machine, but then they go checking it in thinking, oh, it's going to be fine. And the source control system will let them merge their changes in, and they may see that it was a successful check-in, but because they're 3 days behind from the latest update, it then breaks the build in an unexpected way because they're afraid that if they update, they're going to get a bad set of sources, and then they won't be able to check their stuff in, and then they're going to be blocked. Like they're not going to be able to do anything further from that. So there is kind of a disincentive for people to do the right procedure when they don't have confidence that the current set of active sources is stable and working.
Right, because most teams these days don't do what we used to do in the old days, like exclusively check out a file and you're the only one working on it. Like you work on the file and then we merge, or else
Exactly.
down. Yeah.
Exactly.
So then I'm checking in every single check-in that comes in. A build is kicked out. I know if it's going to be broken right away. I can test it.
Yep. Exactly.
Cool.
So John, let me ask you a question.
Go ahead, Bruce.
Since you have so much experience in this space, because you're resonating with the problem we're trying to solve exactly. When that build broke at Disruptor, who was it who had to go figure that out? Was it your most senior guy? Was it your most junior person? You know, how does that dynamic work out in a studio?
Well, so it changed over time, but it almost always could involve like one of the most senior engineers, because like that's the person with the most perspective on how all these pieces are fitting together. What we tried to do is have a fairly senior person who supervised it overall and kind of established what the build process and the integration process was. But then we would have, we didn't really, I don't even want to call them a junior engineer. We didn't really have any junior engineers at Disruptor BM. Like everyone was fairly veteran, but a less lead engineer, not quite a lead engineer, would kind of be more the day-to-day person. And they would be the first line of defense, and often they could resolve problems. But it could get back to like lead engineer for the whole project if things were really breaking down. It could land back at the VP of engineering, right? Our head of Dave Cham, our VP of engineering for a number of years, super engineer who could be hands-on and high level. Like he would get pulled into stuff if things were breaking. So like, it's whatever happened. Like you're right though. Like if the build is broken, people can still build on their machine, but like a lot of things grind to a halt if you're not able to get code running with everybody's recent changes.
Yeah, that's what we're seeing. We're trying to figure out where we fit in these studios, and we've heard this again and again. It's one of your most senior guys, and instead of working on that build issue, they could be building a new feature that actually helps the game, get to market or something that the players love and enjoy, right? So that's also a problem space that we're trying to solve.
Mm-hmm. Okay, so how do we do this magic of every check-in creates a build, and then how are you using AI to help diagnose the issues?
Yeah, so I'll talk about the every check-in aspect of it. So we have a large build farm, and we hook up to the source control so that even if the build takes a long time to build, which is frequently, the issue. As long as a build comes out, even if it maybe takes an hour or two, as long as the build comes out per build, you still know what check-in caused the problem. So in terms of having long build times, we just handle that by having a fairly large farm.
And you're offering essentially a cloud build service as a service to
we
clients?
actually, we do there's some similarities between us and what you guys provide. We have our own private cloud. We have that knowledge and ability to create and manage that. So we have a data center here in Austin. It's a tier 3 data center. And we're in the process of getting our SOC 2 Type 2 security certification. Security is hugely important to us, as it needs to be if we're handling IP for our customers. But in that data center is where we would do our builds for a lot of our customers. Our system can also work on premise. So for larger enterprise customers, we could actually just take our system, install it on whatever servers the enterprise customer would like us to be on, and we're off to the races. So for the AI component, which I think is what is really amazing, I'll hand that over to Bruce to talk about.
Yeah, so AI lives and dies based on of data quality. The question that we've been asking at UC Berkeley to our executives is your data AI ready, right? It's not just is your company AI ready. So what we found is that, especially in the build process, when you get your logs, they can be massive, super overwhelming files, right? Some of these logs for these companies, some teams that we're partnering with for our beta, are like over 100 megabytes, 300,000 lines of log files long. It takes a senior person, an expert person, to even dig through that and figure out what's going on. So how do we democratize that? And so we started where probably everyone starts. It's like, how far can we get with ChatGPT or Gemini or Claude? Can we just put the file in there and start prompting it and say, hey, what's going on here? And what we find there, based on how the systems are architected, is they're probabilistic functions, right? They're not deterministic. So they are looking for predicting the answer that you want to hear. And when you have that much context, they experience this. It's almost a form of hallucination called context rot, right? Where it doesn't actually know which piece of context is the right piece to predict to give you your answer. And the way that we overcame that is actually going back to fundamentals, first principles. A lot of the work that I did at Shell, I was actually some of my favorite work that I did was actually a root cause analysis, root cause investigation. So bringing back the fundamentals of that, when you get your data in, what's the first thing that you do? Right, you find the data points in chronological order that, so for example, something that happened after the main event, the breakage, something that happened after that couldn't be a cause. You put in these these rules into the system, then you just start cleaning the data. You start doing your standard, data removal, data clustering, trying to figure out what the patterns are into that data before you start deploying these amazing technologies that we have, that are called large language models, that'll help you actually make sense of all that data that you've actually architected and put together into a nice package that it can then use to say, hey, this is the root cause of your problem, and here are secondary causes, and so go fix these things in this way, and you should back off to the races.
So I want to introduce a whole other layer of complexity because I'm curious how you think about it. So we've been talking about build process so far, but I'm assuming that we're talking about a singular piece of code where I make changes to it, like the game client code, essentially. There's this other aspect of what happens with servers. And I want to just maybe talk a little bit about what we found at Beamable, because this is a big part of our solution that we found became important for developers. So in creating most modern games now, like 95% of the revenue in this industry comes from games that are online in one way or another. Whether you call that games as a service or not, it's games that require content updates or have some kind of even just an asynchronous online component, or it could be full-blown Call of Duty, Battlefield, real-time multiplayer game experiences, but virtually all games have an online component. So that means you now have a mixed code base, which is client code for the game, experience layer, graphics, etc. And then you've got server components. And the server components have to work harmoniously with all of the builds. So for example, just individual developers workstation, for example, you have to run your build not only with code that works in terms of like your local code repository, you have to make sure that all of your connections out to various servers and services that are part of your game are also synchronized and you're using all the latest stuff there. So what we discovered was really important was developers want to essentially instantiate the entire server environment on their local machine so that they could test it locally. There's other needs to also test against staging servers or even production servers, and QA does different things. But just for that individual developer, we found that if you make them connect to like the shared dev server, like that doesn't work that great because they have to make changes to dev server components at the same time as they're doing client, and everything gets out of sync. So they have to be able to work on things holistically on their machine. So part of the solution we found is, first of all, get people on one language structure. So if you're programming in Unity, for example, just use C# top to bottom, including your server components, and then use Docker to containerize all of the server components, make sure you pull down local containers that are the authoritative versions of the server code that you're going to depend on, and recreate that whole environment on your machine. And then not only are you testing it locally, you're testing it locally, you can also debug locally. So you could set like a breakpoint on server code and initiate it from client code and trace it all the way up and down the stack. And you can only really do that effectively if you're on one language with all of the code actually runnable on local. Okay, so that's just the preamble. That's kind of part of the magic of Beamable and why some developers really like us, is because we integrate the whole development process, including debugging and stuff like that. But now I'm thinking about what you do and thinking about the build collectively, because you still have to ship all these pieces off to the staging server where QA is going to sign off on it, and other developers might get the current version of the server components. Or it may also have like more complete, like a common thing is like the more complete databases there. Like one thing we did back at Disruptor Beam is we'd actually back propagate the production user database back to staging so that you could test code against, because we didn't want to break production data on production databases. We wanted to test the environment against a mirror, essentially, of what had been recently on production. So like so much complexity when you start having databases and server components, all of that. So now I'll take a step back. I've talked about kind of the piece that Beamable thinks about. How do you think about all of that interdependent complexity that happens with server code when you add that to the
100%.
already complicated?
Yeah, and I would say that the most common client that people are going to be developing for, certainly it's all over the map. Most common, I think, is Windows, and a lot of the server components they'll only run on Linux machines, or they'll only run effectively on Linux machines. And so now, if you want to run everything locally, you have to have a multi-machine kind of local environment, which can get very complicated. We handle that in a couple ways. First of all, for every client build, we can produce a server build. And we can specify like basically what components, what versions of what components need to be part of that server build. The way we handled this at Magic Potion Games is we had a development environment, obviously a staging environment, and a production environment. And anytime we did a build on the dev sources, that would produce a client and would produce a server build. And then our system would automatically basically load that C# executable that, like, let's say Unity produced, load it and make it available to all our servers, so that when our client launched, we could guarantee that your client was going to attach to a matching build so that you didn't have any sync issues. And so in Magic Potion Games, initially, we were using dots. And so, we're using Unity 6 and dots. It's basically required that you build a client and a server and have those match. And so we actually had like a meta server that the client would connect to. And then that meta server would make sure that there was a server instance running that matched the client version that got built. And so then any client of that version would connect to a server of that version. So if multiple people were running the same client, the same version. They would be essentially on the same server, but different people could be running different versions, and they would get their own server environment. I think in practice, it definitely is very, very useful to be able to set breakpoints in server code and see that happen and see the interaction. And that's definitely the preferred way of doing it. That can get very problematic, particularly when you are basically having set breakpoints on a Linux machine because your code there has to run on a Linux machine. Also, all these systems are real-time systems, and so when setting breakpoints in a real-time system, that affects how the real-time system operates. So what we found is the most effective way to do bugging in that kind of environment is actually through logs, and that can be difficult. It can make your eyes bleed when you have a super long log file, but that is going to be the most effective way to debug a real-time system where you just can't put in a breakpoint. And so we actually, this is something we haven't announced yet, but we are working on systems to basically make that process much more friendly. I think actually analyzing log files is very similar to analyzing the results of builds. A build log file can be 100 megabytes long. It details everything, and our AI system learns from that. You can actually apply very similar technology to analyzing log files, where it looks for something that it hasn't seen before. It looks for a pattern of logs that it thinks hey, this is not the usual pattern of behavior that I see. So it can really be super amazingly useful for helping you find anomalous problems, anomalous work paths that that lead to bugs or lead to unpredictable behavior. That's something that we're working on as well, is that complete picture, so that everything works from the client to the server, and we make sure that builds stay in sync.
I want to understand again the AI component a little bit more. So Bruce, you were explaining a moment ago context rot, all these things that can sort of go sideways, I guess, when the source state. It sounds like context rot is a consequence of supplying a very large amount of inputs. Did I get that right? So
100%.
Throw the 100 million lines of log code at it, and it probabilistically finds issues that are not the issue. It's just pattern matching. It doesn't have enough supervised learning around that particular data set to actually, or any kind of reinforcement learning, I guess, to gear it towards the more specific solutions that would be appropriate in that situation.
Yeah, you nailed it, John. Absolutely, really, really well said. And part of that is because if it's probabilistic, it's looking for the things that are happening most often. And then oftentimes these build breaking errors are like 1 in 10,000 lines, right? And you're asking us to look for a needle in a haystack.
Okay. So take me through that a little bit more, though. So how do I find the 1 out of 10,000 lines?
Well, yeah. So I mean, humans are good at this kind of thing, or we've been trained ourselves on this kind of thing. That's why we have investigators and the detectives. It's using that really methodical approach, using our discipline, and there's really a lot of creativity to it too, that I think that maybe the machines aren't ready to do yet. Which is just taking things apart line by line chronologically, using some rules very specifically. Is this particular potential cause both sufficient and necessary to result in the error that broke the entire build? Checking everything. At least twice, right? We have a double verification system, but checking every input, every precursor to a cause, to make sure that they're logically, reasonably connected to cause the upstream issue or the downstream issue, however you want to say it.
Bruce, one of the things I'm curious about, so the context size and this context rot problem, I get it. I guess the lesson from AI generally is like, okay, you run into this problem, you scale up to a bigger LLM, and the problem goes away. I'm curious if you've tracked between major LLM versions. It sounds like you worked with ChatGPT, for example, or OpenAI's interface to the underlying LLM. Have you seen that problem not really resolve relative to, say, size of the model as they've scaled out? Is it a problem unrelated to scale?
John, I think that's a brilliant point of view. And so we're actually one of the systems that I tried on early in prototyping days was Gemini, which has one of the largest context windows of all of the major providers. And even in that, even if you played with Gemini and you were having a continuous conversation, after about 30 back and forths or so, it starts forgetting. You say, you could say, hey, I told, we specifically discussed that I don't want to talk about that, and it'll bring it back up. So if this is a symptom of that context rot. So yeah, I don't think that this is a problem that can necessarily be solved by scale. Because
it's funny you say that, Bruce. I'll give a funny anecdote, and maybe it's the same kind of thing. So ChatGPT in recent versions has gotten pretty good with its memory, and sort of giving results based on its memory of all your interactions. And I don't drink, or do it extremely rarely. And this isn't a bragging point at all. It's just more a ChatGPT point. So I've told it that, but without fail, every time I tell it, help me organize a trip with some real highlights in this area, I'll get, hey, go to this brewery, or go, this place is known for its wine selection. I'll be like, I've told you this before. That is not a thing that I'm looking for. Revise, and so I have to go through invariably a second process where I'm like, okay, revise it with that out. By the way, remember this, please. It's important. I just don't want that. So that's just kind of one example. And I'm sure if anybody out there has used ChatGPT, you've seen all these versions of the same thing where it forgets a key memory and just it doesn't stick, even when flagged as important.
John, that you nailed it. You absolutely nailed it. And so I guess one way to get around that is through training or fine tuning, right? So you could take your own model and essentially eliminate those nodes within it so that it doesn't need to know that John doesn't drink. It just won't talk about drinking at all. So that's one way to get around that problem, and that's called fine tuning. For us, we are very much building a system that is a specialist, a root cause analysis specialist. Whereas I think the ChatGPTs, the Geminis, the Claudes, the Groks of the world, they are amazing generalists, right? They know a lot about everything. We want this system to know a lot about builds, how log files, how they break, and how to fix them. So that's another different way of thinking about it.
Yeah, at the same time, we really see language models doing so well at coding generally. I didn't expect that code assistants would be 2 years ago, I knew code assistants would start becoming amazing. But 5 years ago, it wouldn't have been my guess that we'd now have vibe coding and computers through AI models would be so good at generating code. What's the fundamental difference between generative code writing that we see LMs are getting better at? And actually, that's an assumption, so maybe I'm begging the question a little bit. Happy to have you take any varying view on that, or maybe point to the limitations that are possible in at least current generative code. What's so different about that versus poring over a log file in your example?
Well, I think it's got a lot of training data. When I was actually looking for training data for log files, looking at Stack Overflow and such, I think, and people can check my numbers here, if I wrote my queries right, I was only able to find 24,000 Unity log files on Stack Overflow that had both a question and an answer to them. So, and if that's the data that was used for, for whatever large language model, then it just doesn't have a lot of data in that space. But it has a lot of code examples from GitHub, from Stack Overflow, right? That's one possibility.
Parallels in some ways what we're seeing in game development, which is 2D art generation is really, really strong because I don't know how many 2D images on the internet. There's close to infinity 2D images on the internet or something. And then there's lots of video as well. So huge amount of training data, but with 3D modeling, it's actually proven to be a harder problem. There are people actually doing a really good job at it. Like there's a company out here in Cambridge, Common Sense Machines, who's building a new foundation model just for 3D. So like there's examples where people are actually doing pretty good at it, and you can see that they'll eventually get there. But part of what has made the problem so challenging in 3D is just that lack of training data. There aren't tons and tons and tons of 3D models present on the internet that you can just train everything up and then just prompt everything into existence. So that problem I get. So people are just not posting their log files to the internet with their problem description and the code solution.
Yeah.
Otherwise, so I don't know if people start doing that, and we start having, I don't know, probably millions of log files. And I think you said 20.
It's 24,000. 24,000.
24,000. It's still a lot, but not enough, right? We probably need like 24 million or something.
Right.
And then we can start just LLMing the way. So again, but it does speak to a kind of a scale problem. Sometimes it's the scale of the model. Sometimes it's the scale of how much training data is available. So you have to build a specialized approach to this market based on expertise, I guess, and the ability to take I don't know, to the extent that you can talk about it, because maybe I'm starting to get into secret sauce territory for you guys, but I'm just curious, like, how do you go about that? Are you effectively building a new foundation model that's specific to this problem, or is it like, what are we building here?
Yeah, so I mean, we definitely entertain small language models, fine-tuning models so that they're very good at a certain task. But actually, so this is not an industry secret or anything. Even when I was back at Shell, that's like 20 years ago now, we had lots of automation, lots of optimization. But we found that when we first went into, let's try to optimize how this reactor runs. The first step that we take is go talk to our most senior operators, the guys who've been running this thing for 10, 15 years. They could do it in their sleep. And so say, hey, so what would you do in this situation? And then start, having our systems learn those rules, right? And so then we're operating these things based on trying to mimic what humans do. And a lot of the machine learning models that we've developed, like neural networks, we're trying to mimic artificial neurons, which are trying to do the things that our natural neurons do, right? Any sort of regression models, these are all just mimicking how humans perceive, and project extrapolations, right? So yeah, I think that's the secret sauce. Is we just took a very systematic step-by-step approach, like you said, an expert methodology to say, hey, how would a human approach this, and then how would an expert senior engineer approach this, a dev engineer? Yeah, we got some pretty good feedback from some of our senior engineers saying, yeah, this is cute, but this is actually not the right root cause. And so how do you make your system a little more? Oh, by the way, John, to your point earlier, a lot of our LLM systems are programs to want to please. Right, so they'll find like the first answer, and they'll be like, "Oh, hey, I found something. Here you go." So we had to tune our systems to say, "Hey, we don't want the first answer. We want the best answer." Right.
Interesting. So you are working with game developers who are going to use this technology to solve the problem that we talked about at the outset. And if you're tuning in late, it's people break builds. And so the solution is basically kick out a build every single check-in of your code and couple that with some, I'll call them diagnostic tools. I don't know if that's how you describe it, but tools that give you insight into why that problem happened so that you can then fix the build more quickly, get your build process on track, get it into QA, ship faster, increase development velocity so that you're not paused by these problems. So I'm guessing that in talking to a lot of this market, you get exposed to how a lot of game developers are thinking about things like AI and where AI is applied within their business. And you have a specific solution that is using AI to solve a specific problem. I think often in the industry, there are conversations that are kind of speculative, aspirational. Hey, someday we're going to vibe code Call of Duty, press one button, Call of Duty is now downloaded to my computer. I can start selling it. I actually do think that's possible someday because there's no law of physics that says we can't, but might require a lot of energy, Might be more expensive than people expect to do that, but I think we eventually get there. But in the here and now, like the reality that we exist in this moment, where do you see people really applying AI in game development? Like, where are the actual wins right now versus, and it's not really something that is anything beyond like sounds cool, looks cool, but can't be used in production?
Yeah, maybe I'll take the first crack at that.
Yeah.
Yeah, so I mean, I actually do a lot of engineering work. My background is in tech and software engineering, and I think the current state of the art, it's relatively limited. I mean, I'll just like digress for a minute about how I view AI and how I approach using AI. Like, I've actually been around long enough to remember when like using calculators in the classroom was controversial. In grade school, calculators, that's how old I am. Calculators, all of a sudden became affordable to use in a classroom, and it was a huge controversy. All the teachers had, their arms, all twisted, like, oh my gosh, how can these students all use calculators in the classroom? And obviously now that's like, a no-brainer. So I would say that was like one like kind of generation, like revolutionary tool that kind of came about. Obviously, calculators super simple, but it was pretty revolutionary at the time. And then personal computers came out, and then everyone was typing their term papers on personal computers and editing their term papers and printing them out on dot matrix printers, and that was hugely controversial. Like, how can you not be using a typewriter? How how can you be using this personal computer? Like, and that was kind of like a second major revolution in terms of like how we worked. And
I remember when like grammar checking was terrible.
Yes, exactly.
I remember in
Grammar
the
checking was cheating.
early 90s,
Yes.
grammar checking was actually controversial. Like, oh geez, now you get a free pass on grammar on your English paper because you could just grammar check it in your word processor.
Yeah, exactly. And I think AI today is just another iteration, obviously much more sophisticated, much more complicated, and maybe a much bigger impact than those. But I think at the end of the day, my point really is like AI is just a tool. There's no AI system out there like acting like a human or thinking like a human or initiating things that need to be done. I don't know if Oscar agrees with me, but that's fine. Like I think what people lose sight of is they hear things like, oh, Microsoft laid off 30% of their team because of AI, and actually there's not like there's like AI directly replacing what the 30% that got laid off were doing. Like they're not taking initiative. AIs are not like deciding, hey, you know what, here's a great new game idea that I think we should all be building. But what AI is doing is it's making engineers, in my opinion, is making engineers 30% more productive. And it's doing that through like what you mentioned earlier with like vibe coding. I mean, I found AI to be extremely helpful to ask it for very narrow things. It's like, hey, I need a function that does this. Like, I'm unfamiliar with these Win32 API calls. How do I use this particular Win32 API call to get done what I want to do? And then it will give me a function, or give me that that answer, and it does an amazingly good job of doing that. But I wouldn't say it's turnkey either. Like, I would say like usually the AI will make some mistake, or there'll be some context that slightly gets wrong, but it gave me a starting point, and now I can make that do what I really want it to do, and it takes me maybe 5 minutes instead of taking potentially multiple hours. And so it's just made me more productive. It hasn't it hasn't replaced the the inspirational, the creativity part of what humans do. So I think when you look at how AI is applied to gaming, I think people that find a way to embrace how to use AI to make them more productive, those skills are going to be more valuable to employers. And I think it's human nature to be scared of something that they see that they think could replace them. And I think it's a traditional, like, if you're scared of something and you shun it, you're not moving forward. you're not moving ahead with your skill set and improving your craft. Whereas I think if you, looks like maybe we lost John, but I'm sure he'll be back.
He'll be back in a second, but please continue.
maybe what I'm saying is making him so angry he had to rage quit. But I think, my high level piece of advice is I think people that figure out how to use AI in their jobs to make them more productive, that's just going to be, I think how the future is. And so I think, it's totally human nature and normal to have a knee-jerk reaction and be afraid of something that you view as a threat. But if you can figure out how to flip it around and actually make that work for you, you now have new skills, and those new skills are going to be, hugely valuable on any game development team.
Yeah, I find it important to acknowledge that people's fears are based in an existential fugue. Like, people are scared that their function, their role is going to be replaced. And there's a lot of people who are just absolutely rejecting the technology or the workflow or the tooling, on its face, just because of that philosophical contradiction. And this is not an isolated incident. You could look at the same thing that happened when, not that outsourcing is like a brand new thing, but like we saw like an exportation of work to places where things can be done cheaper, and people get very protectionist about where they are, what's going on with them, what they've built their entire identity around, and like their purpose, for lack of a better word. And the scary thing, I think, with AI is that I can say in the next 1,500 days, what we've been seeing with vibe coding is going to scale up to a point where maybe it'll be really tight integration between Unity as an ecosystem and built-in agents. I think they actually just rolled in built-in agents of some sort in Unity to answer questions and to provide, hey, just try this. So I remember specifically between the time that Unity was introduced and Unity became the most hated thing on Steam because of all the shovelware that everyone was like really, ticked off, that like, oh, you're not real coders, you're not real developers, you guys are a bunch of, you just asset flip this and bum. And if you did not pay to get rid of Unity from your, from the opening,
from your flash screen, yeah.
Right, then that was a problem, and that could actually affect your success on Steam, for example. So right now, we are going to see a big flood of games coming into the marketplace as a result of AI facilitating people not having as huge a lift. And that's going to be the exact same thing with like maybe a 5-fold, maybe a 10-fold increase of like titles on Steam over the next couple of years. The difference will be eventually, is the technology going to reach the point of fidelity where I can say in the next 5 years, I want to make a Call of Duty, and like iteratively, like you get close enough to be like, oh, that's not Call of Duty, but it's not, the worst piece of shit that ever happened. And good enough is a hell of a litmus test for entertainment. I don't know how many kittens singing like that Billie Eilish song with like AI, domestic squabbles, but that became very popular, and that is entertaining and engaging content. So I can see that same level of automated, quick turnaround, tied to the news cycle. Hey, I've got a game. It's out there in a week. I sold 10,000. That's all I needed to, to cover my nut. But that's a whole separate conversation from, I don't think that we're going to see a massive like die off of like game developers, in the industry. But I think that there is going to be a situation where there is a conflict where people who are not rejecting the tooling, people who are using AI in their workflow are going to receive preferential treatment when it comes to hiring, when it comes to production, when it comes to leadership. And there's going to be people on the other side of that equation, like the indies, people who they want to make their point and click adventure. They want to make their visual novel. They don't have to wait for art. They don't have to budget for, they don't have to do like crappy, janky pixel. Not that I'm knocking crappy, janky pixel art.
Mm-hmm.
vibe coding in some ways it's the future, and the counter argument is you guys are stupid. I've been a developer for 20 years. You guys don't know how to debug. Everything sucks. You're horrible human beings. Blah, 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 blah. I mean, I spend too much time on
Yeah, no, I
Reddit.
mean, again, I think that gets back to the human nature, reaction to being threatened. I think it's totally understandable, and I have a lot of, a lot of sympathy for what they're going through, because it is a bit of a struggle. But I think at the end of the day, what matters is what people are going to want to consume. Like
Yeah.
like as a game user, like most game users probably don't really care how it was made. It like all they know is here's a piece of content, whether it's a game, whether it's a movie or a short clip, whatever it is, like a TikTok video, like they're going to care. Hey, does this affect me? Does this resonate with me? Does this enrich my life in some way that I enjoy? And they're not going to care so much about how that got created. And I think what developers, I think the trap they get into is, oh, people care about this because I made it, or people care about this because a human made it. And I think that's not that's not at the end of the day going to be a mindset that helps people stay employed doing the things they love to do. I think the mindset that keeps people employed is, how can I make myself the most relevant? How can I make myself the most useful to create the content that is going to connect with people? And I think when people embrace the state-of-the-art technology that makes them more productive, that allows them to do more things, they're the ones that are, at the end of the day, can be the ones most valuable, because they're going to be able to produce the content that people want. I think, I think also, what's happening with AI tooling that personally I think is super cool is it's enabling a lot of creative people to do things that they couldn't do before. They, like a creative person may not have had the skills to, write all the complicated engineering code that is required to make the content that they want to create. But if AI can help them do that, then in many ways that's a pretty cool thing. You've now empowered someone to do something to affect other people in a way that they couldn't before. And so I think that this is a transition. That this is a big change. Whenever there's change, it can be scary, but whenever there's change, there's opportunity. And I would encourage everyone who might be listening to do their best to think about things, not from a selfish standpoint, but think about things from more of a macro standpoint, and ask themselves, what skills should I be learning to make myself more relevant in the world that I want to participate in.
What's going on?
I don't know if I lost you. I mean, maybe I cut out for a second.
No, that was. Yeah, please jump in.
I can just check, because I think that leads perfectly. I think that would have been a great way to end the conversation. John asked before, what technologies have we seen in that space to accelerate what you're talking about there, Brent? And I was just thinking about Titan AI, who we're talking to in a little bit, who is using generative technology to overlay different genders and different ethnicities onto playable characters in games very, very rapidly, right? So Oscar, to your point before, what kind of content do people want to consume? I want to play a character that maybe looks like me, or maybe doesn't look like me, or something like that. So be able to create that content in a very effective manner. I think that's awesome. The other thing where I've really seen a huge improvement is internal communication. So the ability of somebody like a designer or a product manager to say, hey, here's the data that I've gathered on what our audience wants, what our players want, and here's how we should design it, and to be able to mock that up super rapidly using vibe coding or other tools like Figma and Figma AI, to then get to the engineers to be like, hey, this is what we need, and this is how it should work. If I were to have a wish list, Oscar, I still haven't seen any tools to help with like economy design, because when you create a piece of content, and I learned this the hard way many times on FC, that it can break the whole economy. And that's oftentimes, it's not the content, it's the content plus the economy, plus the systems, plus the gameplay that makes the entire thing super fun. And if you break one
Yeah.
of those, it can break the whole thing. So, that there's maybe an idea out there somewhere to have some sort of AI system to help economy and balance economies, right? That's super complex.
It's incredible. I mean, I always think back to one of the first things I learned in, I guess, maybe project management, where it's like, I can tell someone, make me a sandwich. And it's like, there's a lot of assumption that goes into that versus like a detailed step-by-step. There's like, get the bread, do this, blah, 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 blah. You can take any concept and atomize it down to like an infinite, you can go all the way down. It's all hurdles down there. And the last thing I vibe coded was either a 2D/3D video poker. I spent an afternoon doing it, or I cloned a couple of Atari games. I did a solar system simulator with like real data pulled in from NASA and here and there. And there's so much. If I even wanted to, as a designer, as a project manager, as an idea guy, that should be the name of my next company, Idea Guy Interactive. It's one thing for me to say like, hey, let's make a simulation of the solar system. It's like, okay, make me a sandwich. What the heck does that even mean? Where do you start? What's the tech stack? Bum, 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 bum. And for someone that doesn't know how to ask and answer their own questions, or at least know how to start investigating and coming up with like proposals for how to address, the what's in the sandwich question, like it's overwhelming. Like think about how you calculate orbits. I don't know how to do it. I studied it at one point. But to be able to sit there and dynamically get answers for like, okay, how do the physics work? How does how are we doing this in 2D? Are we doing this in 3D? What library are we using? It's going to be 3J, this, that, and the other. It's like, and you don't have the capability of answering those or implementing all those different tech stacks, like wiring all that stuff up. But to be able to sit there and orchestrate and iterate and double check and make sure and catch the error and research the error and feed the answer back in through another AI that's looking at what you picked out of, and then have all that at some point after 3 or 4 or 10 things don't work, and then it lands, and then you can share it on GitHub pages. And it's still, it seems like it's insulting a lot of people, but it also seems like there's a lot more people who can have a problem, address it themselves, and have that scaffolded out into a working, even if it's like, duct tape and bubble gum and MacGyver, to see something working, to prove it, and then to be able to hand that off to someone and have them develop it in and of itself is an incredible leapfrog, in the way that we've done things in the past. It's like an MVP in a weekend versus a month. That changes a lot of paradigms. But I've rambled on too much. John, you back? Or are you still doing the robot? I think John's connection is still a little choppy. John? No.
Okay. Yeah, I mean, I totally. I mean, again, I think that's such a great example of how AI helps people do things quicker, and maybe just to go into a little bit of like workflows around AI, like when you're building that sandwich and you're giving it the steps to create the sandwich, or in your case, the planetary example, it's like, you need sometimes, like, you need to go back, you need to go back a couple steps to change what you said, and then kind of go from there. And I think that creates like some very interesting workflows with AI that I think we kind of took for granted when we're doing traditional development, because in traditional development, you're making changes to your sources and you're checking them in. You've got like a history of every change that you've made, and you can go back in time and grab those changes and then say, okay, you know what, actually, this is not what I wanted to do. I want to do something that branches off that,
Mm-hmm.
and then you can make forward progress. Whereas I think when you have the AI vibe model, it's a little bit more challenging to have that workflow where you can kind of like, take me back 5 steps, and then let me do something different and then bring that forward. So I think there's a lot of interesting things that still need to happen in terms of like the development process for how we like vibe code.
I fundamentally, I think that there's still that, no matter how agreeable the AI is or how much it understands what you're saying, like it's very easy for us to like see faces in the clouds or to believe that there is like an actual comprehension or intent when it's instead it's it's probability spitting back out at you, with a lot of bells and whistles to make sure that you feel present within that context and you feel addressed and you feel engaged. The quality of the math that's like spitting out responses at you, it's ever increasing. The value of what you're receiving in response to your engagement, that value is increasing, which is why I see so many people freaking out every time a model changes, like the GPT-5 debacle, where everyone's just like, "Oh, I lost my computer boyfriend." It's like, yeah, dude, I feel you. When my internet goes out, I lose my mind too. But I mean, ultimately, I think AI promises, very transformative opportunities at all levels of development and creativity, and not just on the creative side, but on the technical, on the quality assurance, on the ability to assure that you are increasing productivity by decreasing headaches and late nights and red eyes waiting for something to work when it should work, when it did work and it stopped working because you are in concert with 10 people or 50 people or 100 people. So I mean, it's my sincere hope that DevStream Labs like brings more clarity and continuity to people's ability to work. That's ultimately that's the most important thing, and that's the majority of budgets just get eaten up by both sitting around waiting for things to start working again, in my opinion.
Yeah, no, thank you for saying that. I mean, I think as we've gone out and talked to people, we've talked to some CEOs of some big service providers out there in the game community, and the theme that we keep hearing back is the broken build is a major pain point, and they don't know what to do about it. We've heard stories of the build being broken for a few weeks, and they have their team of engineers that cannot be as productive as they could be because the build got broken. And so this is absolutely something that like in moving forward in the future, we don't want people to think about like the build being broken. It's like we want to us and whoever else is doing this, we want it to be a solved problem. We want to be part of the ecosystem that's providing that service to solve that problem, so that people can focus on doing what they want to do. People can focus on doing what they love to do, which is creating, which is making something. And when you have to worry about any aspect of your underlying infrastructure that's enabling you to do it, that's just taking time away from doing what you truly want to do. And I think what Beamable is doing and what we're trying to do, I think is really a fantastic service to people, so that they can just focus on doing what they love, and they can let the commoditized problems be solved in a general way, and that can be shared amongst all development teams out there, because at the end of the day, that's just not differentiating. The creativity of their product and the mechanics of their gameplay and how they engage with users, that's where the differentiation should be, and that's where people should be able to find the different kinds of content that they want.
Absolutely. Well, we just passed the hour. Bruce, if you want to, wrap up on your end, if there's anything you'd like to share before we close out the episode, I'd love to hear what you got to say. I mean, but no, this has been an amazing conversation. Thank you both so much.
No, we exist for all, we're part of the dev community, part of the game community, so we exist to help this community. So thank you so much for having us on. Couldn't be more grateful to Oscar, to John, everybody at Beamable. Looking forward to doing more together. Thank you guys so much.
No, and just everyone in the audience, John asked me to express his his apologies. The internet is a fickle mistress at times, and he caught the short end of it this time. But we'll be back soon, and we look forward to more conversations with you, our lovely audience. This has been the Artificial Intelligence live stream, and everybody do good things and be well.
Thank you, everyone.
Thanks, everyone. Hey.
And